Good afternoon, everyone. Welcome to the first technical presentation of this next round. Mark and Nathan from Atlantic Pumps, who are going to very kindly agree to give a presentation, and hope you enjoy it. So, guys, over to you.
Thanks, Mark. Appreciate that, and thanks for joining. Just we make this inspiring, and I trust it's not too simple or too complicated for anyone. Any questions, then we'll have to answer those at the end. But equally, I don't want to try and teach you things you already know, but it's useful to go over some key facts. I'm Nathan Rowles, Sales Director at Atlantic Pumps. I've got with me here Mark McCreadie, who looks after UK and Ireland customers. A lot of you on this call probably have been in touch with them before. And the key topics we wanted to cover off today was some innovations in the pumping sector relating to the quarrying market, and also with a bit of a focus on best practice in relation to site water discharge. As you probably all be aware, the Environment Agency is getting hotter and hotter on this topic. It's a conversation that's coming up constantly in our office with requests from clients to help them out. Probably a little bit of education piece needs to go with this in view of giving the sites the best assistance to be able to be compliant with the latest regulations from the Environment Agency. So that's our two main areas. I suppose just by way of introduction of our company, many of you all know, but we started off in the mining and quarrying market back in Australia in the 1960s. We focus in the mining market globally. We established in South America also. And back in early 2015, we established in the UK and brought our products with us. So with a strong focus on exporting around Europe, but also servicing the home market. Not much mining left, but plenty of quarrying. So our product range suits that market. It's not very a sales pitch, but just some examples on the screen. We'll go into those perhaps as we pass on later in the call. So without boring you, we're just going to go into just very quickly, just run through how you specify a pump. And the reason for this is why we find this is important is a lot of you are in a position where you go out to suppliers and make a request for a pumping solution. It's really important that you understand some of the terminology they might come back with and some of the questions they might ask so you can understand why they're important. Any quarry application, and I think we're in North Wales today, you've got a lot of hard rock, got plenty of dewatering to be done. Pretty much any quarry, there's some movement or transfer of water, whether it's for processing or whether it's for emptying the quarry, keep it dry. But all that water, despite it being defined as clean water, is not clean. And in the, I think we had an instance once, a quarry fitter was trying to explain to one of his colleagues how the dirty water was actually dirty or clean, what was called clean water was actually dirty on a quarry site, and his mate on the quarry refused to accept that this water was dirty because it looked clean. And I think he eventually told him, right, okay, well, you've got a lovely BMW M4. Why don't you pop your so-called clean water into your wash wipe and then see how you get on. And I think that once that little experiment had taken place, it was a proof that no water is clean in the quarrying industry.
There's a lot of suspended solids just from yard runoff. It may look clean on the surface, but it may just be the 10% at the bottom that once it gets stirred up causes the problems. But then that's the case for having the right tool for the job. It's not unmanageable by any manner of means, but it's just ensuring you've got the right tool for the job.
Agreed. So with that in mind, we're just going to run through quickly some general pumping principles. We've got a very simple diagram here. On the left-hand side, let's imagine that's the grey area here is a lagoon or source of water. On the far right-hand side, let's imagine that's a wash plant, for example. And this is the route to get the pipe run between.
One thing that might be worth mentioning here is that often while we run through these questions is because it's not necessarily, when you ask for a freshwater pump, dewatering pump, it's not necessarily, if we have the model number of the current existing application, we're able to go through and just specify products based on existing specification, because different pump models differ massively. So we like to do this process every time.
That's really important point. So we've had instances in the past where a pump has failed on site and we go in and the previous pump may have lasted 10, 15 years, and we go in and replace it in our innocence with a replacement pump, exactly the same as the pump that's been there previously, and it only lasts 6 months, and we start to get very wound up about our quality, etc. And then we do some more digging and realise that actually the pump had recently changed its duty or application, and the pump was no longer fit for that revised duty or application. So it's really important to go through these questions every time you do a pump, just in case something has changed. So just going to jump through a few things. So some important things that will, some important words and terminology that will be asked of you when you're specifying a pump. First of all, suction lift. That's the distance between the level of the pump and the level of the water. Vertical head is the distance between the level of, or the vertical distance between the level of the pump and the highest point in the line. And pressure, obviously, is the pressure required at the outlet.
In most cases, it's like spray bars on the, firing onto a screen or
dust suppression or something like that.
Yeah, something like that.
So first thing to point out here is that we put a very simple little pump there on the left-hand side, but that's not going to work. A simple rule of thumb is that any pump cannot prime greater than 7 meters. In reality, more like 5. The laws of physics say 10, but between 5 and 7 meters is the maximum you can prime in any example, in any given circumstances. So in this instance, we're going to have to put in a submersible pump, because obviously a submersible pump is submerged, there's no need to prime. I'm just going to run through some calculations here. So the important number that or important question that you're likely to be asked is, what is your total dynamic head, or TDH? And TDH, or total dynamic head, is the combination of the vertical head, so the difference between the level of the pump and the highest point in the line, the friction loss, which is the back pressure created by the movement of the water or slurry down the line, and then the pressure at the outlet. That pressure point is really important because oftentimes on a sand and gravel site especially, or if you're washing quarry dust, for example, it's often forgotten the pressure that's required at the spray bars. And that's really important. A wash pump wouldn't obviously work without that. So that's the combination. So total dynamic head is the combination of those three things. And we're just going to walk through the specifics here in this example you can see on the screen. So vertical head is 17 meters in this instance. So you've got the 10 meters up to the level from the water level, another 4 meters up to the highest point, and 3 meters up to the top of the plant.
Yeah. Friction
loss. There are plenty of online calculators that will help you out with this, but we'll do this for you largely. The friction loss is typically, should be in any given circumstance, should be less than 10 meters. 10 meters is the maximum you really want to go to.
Yeah, beyond 10 meters, you want to be looking at a bigger pipeline or more different pump, more efficient pump.
Yeah, so that's an important point. The larger the flow and the smaller the pipeline, the greater the back pressure.
The more pressure you have in the pipeline, especially if it's just a fairly basic bar connector, the quicker it's going to wear out, the quicker it's going to wear the pump out.
And let's say we need pressure at the outlet of 1.5 bar. That's 1.5 bars, 15 meters, which is a total diameter of 35 meters. I hope this isn't teaching you all things you already know, but just good to go over this again. So how to read a pump curve, and we'll just fly through this quickly. You can see our example on the right-hand side. Let's say that our typical wash pump might need, say, about 3,500 litres a minute. Let's say that that's our target flow. And on the left-hand side, we have a very standard submersible pump curve. This is a 37 kilowatt, 6-inch. So how you work this is, as with any other curve, you go along the bottom until you meet the flow rate you require. So right there to that far right-hand side, and then up to the head. And where those points meet is your duty point. Now, as you can see in this instance, it's quite substantially off the far right-hand side of the curve and nowhere near the curve itself. So that pump would not be suitable for that duty.
One typical error there can be the max flow of that pump will probably be about 3.5 litres a minute. If it was 3,500 litres a minute, if it's pumping at zero. It's just sometimes you can get confused between the max flow of the pump and what the flow actually is at the head. So
that's an important point, that often on a pump data sheet, you'd often see it would say max flow 3,500. For example, on this pump you can see on the screen, it say max flow 3,500 and max head 95 meters. Doesn't mean that you can do 3,500 litres a minute at 95 meters head. Let's put up another curve there. This is an 8-inch, 37 kilowatt. Again, we'll do the same, 3,500 meters along the bottom, go up the side to 35 meters, and lo and behold, this meets perfectly on the curve here. In reality, in the real world, that virtually never happens. But just for the point of this presentation, that's a correctly specified pump. And you should be aiming to land in the middle 2/3 of that curve for a successful pumping application, either side of that. And you'll be poor on efficiency and poor on lifetime in the pump. So that's just some facts about specifying pumps. I just wanted to touch on that right at the start. Okay, so moving more on to the points about a bit of innovation in the marketplace. I wanted to touch on a few things that we've experienced in the marketplace that have been really interesting to our clients. And first of all, much more accessible, much more affordable, much faster to set up dredgers. And these have two applications really in a quarry site. We've worked closely with a company called Dragflow in Italy, help them define and establish this range. The reason why this is important is because as their processing plant is further and further away from their dig area, excavation area on the sand and gravel site this is, obviously the challenges of transferring that material become more and more complicated. You have various options. You've got load and haul, not very particularly it's costly, and it's also not viewed as very positively from an environmental perspective. Field conveyor is also very costly and also unsightly. As planning challenges become more of a thing, and as you have to develop into new areas, neighbours and planners are looking for new ways for you to work with them to continue to develop the area, maintain jobs, etc., but innovate in view of not causing issues from a planning and an environmental perspective. And dredging is one of the really clever ways you can work with them. And it's Mike Davis is on. Obviously, we're working with him on this from a Subalco perspective, but there'll be other sites that will be interested in this or have a similar challenges. So there's two main applications for dredgers. One is production dredgers, like we can see on the screen here. So that's when I say production, I mean that you can extract sand and gravel, and then take that to a wash plant and sell it. And the other key application, and we're going to show you one example of each, is silt removal dredgers. So previously, if you had a wash plant and you're returning your silt into the silt pond or your lagoon system, previously the most sensible way of clearing out that lagoon was to get higher in the long reach, clear out as much as you possibly can, put it into dump trucks and take it off somewhere else on site to dry out, and then do whatever you did with it. The idea of using dredgers previously wasn't cost effective because they were all very large, took a long time to set up, and weren't really costly for a campaign sort of dredge. So I'm going to touch on silt lagoon clearance in a second, but that's an alternative application for these dredgers. First of all, we're going to touch on this one there. This is Tarmac Kingsley down in the southwest, where we've put in place a dredger in this lake here. It's been previously worked, but it's going down. They've previously worked it down to a depth of about 15 meters. They're now wanting to go down to 35 meters, and you've got a significant volume of sand down there available to be dredged. Didn't want to put in place a full permanent dredging solution, which would have cost them a couple of £1 million, and on massive long lead times. Instead, wanted to put in place a temporary solution. So we put in place the Dragflow dredger, which is a cable run dredge. Uses a pump suspended from the dredge with side cutters, as you can see on the left-hand side, a jet ring blowing fast-paced water at the excavation area to break up the material and then pump it away to the processing plant. This is a clever little system. You can see on this slide here on the right-hand side, you can see the GPS module. So if you can see those lines there, you've got the dredge obviously sat there, and you've got the green line, the red line, and the black line at the bottom there. So the green line would be the current level of material. The black line would be where the level you want to dredge to, and then the red line is obviously where you are at. A system like this can be operated by one man, can pump directly to the plant, very limited human involvement, completely silent, and very limited intrusion into the surrounding area. So all you can see is the dredger. You can have a buried pipeline from the excavation area to your plant, and that could be a significant distance away.
A couple of examples there. One quarry we're talking to in Sussex is in a national park, and it's obviously a massive benefit as an alternative way to transport material there. Because obviously, any noise, sight, sound pollution is immediately picked up on in applications like that.
No, that's good. That's a good point. So this dredger here, just for your interest, that one on the screen there is doing around about 120 tonnes an hour from a location that's probably, a kilometre away from the actual main processing plant, maybe slightly more.
And you can't say, if you've got a hydrographic survey of your own particular quarry, then you can, it maximises absolutely everything out of that dig. Yeah, you can be sure you've got everything. It's not a blind dredge as such, is it? Yeah,
and operates basically like a robo-mow in the sense that it's controlled by two key metrics. One is the amperage on the pump itself. So if it picks up that it's no longer pumping solids, but it's pumping liquid, it will move the dredger around. And also, if it picks up that the weight has been relieved off the actual winch, the depth winch, it will also lower the winch or increase the winch until such a level as it feels like it's dredged the area around it, and then move on automatically. The human intervention is just to keep track on things. I mentioned silt removal. This is Tarmac Mount Sorrel here. This is their main lagoons. That for years and years and years they've had runoff around the site and also wash plant runoff into these lagoons. Some of you on the call may have been there. They're quite small for the size of the site, and they've tried for years to excavate what they can using long reaches. But as you can see in the picture, the far left-hand lagoon, a long reach can only get so far. And from a settlement perspective, obviously what you're looking for is surface area. The settlement works based on surface area, not on depth. So if you keep clearing out settlement lagoons based just simply on clearing out a strip of it or around the edges, the effectiveness of the settlement lagoon is continually reducing. Plus it's expensive, plus it's messy and frustrating for the site.
You can have, on one particular site in the south, you have long reaches causing an issue to the whole road. But also you've got the extra health and the safety aspect of a man on the end of the lagoon and a big heavy machine.
Correct. So what we put in here at Tarmac Mount Sorrel is we put in another cable dredge that will clear all those lagoons you can see today. There's four main lagoons. Simply is run with a cable around the perimeters of each lagoon. So if you're doing that on there around the perimeter, you put concrete Lego blocks in each corner, run a cable around it. They run all around the lagoon, and the dredge runs up and down this area here. At Tarmac Mount Sorrel, that is completely automated. We've uploaded those 3 lagoon drawings onto the computer on the dredge, and it will completely automatically run up and down that area until the material is cleared out or there's an issue. They have a CCTV camera on the dredge. They can keep an eye on it remotely. I think they're actually watching it from over 2 kilometres away, and they won't need to intervene unless there's an issue. For your interest on this particular job, we've also put a small lamella settlement system on the side of the lagoon so that the bulk of the clean water goes back straight into the lagoon, and we pump away as heavy solids as we possibly can. In this instance, actually, Tarmac have got an improved wash plant on site, and they feel that they can get another 30% out of the product that's in the lagoons. So actually they're paying for the dredger very quickly. That's the actual dredger there for that job. So that's that's just dredging from a production and a silt lagoon clearance perspective. Previously, these bits of equipment would have been, as I said, expensive on long lead time and certainly not available to hire. Something that might be worth considering for any applications that you previously wouldn't have considered a dredger for.
This is going back to pumping again. What we've had a lot on sites is sites tend to struggle with pumps that have been specified by an original plant manufacturer. And what you can tend to find with that, with a wash plant that's been installed, what you'll find on accessory equipment like thickener tanks, etc., the cheapest pump available to the job has probably been specified and supplied by the OEM, not necessarily the best pump for the job. One typical application we come up a lot against is progressive cavity pumps put in thickener clarifier applications. They will do the job and they will work, but you will have typically have persistent issues with them. They're prone to clogging. They've got a mechanical seal or a gland pack seal, so after time they will start to leak, and you will end up with a lot of silt underneath your tank. That causes downtime while the area is cleaned or extra manpower. They're quite difficult to maintain. They're not the easiest pump to repair, and they're not the easiest pump to get hold of spares for. You can typically wait a long lead time for them. The reason they're put in, obviously, is because it's probably cheaper for the OEM to put it in, and they don't have to worry about the ongoing maintenance. So in this application, it's important to get the right technology. So if we move to the next slide, you see something like a peristaltic pump. The beauty of these types of pumps are they're very, very low energy consumption. They're very easy to maintain. They don't have a seal as such, so you negate the leakage factor. Also helps keep your site clean. They've got the ability to run dry, so if you do run out of material, they're not going to blow up on you. And they're reversible, so with the clogging issue, if you do a blockage in the pipeline, which is not unknown to silt pipes, you can reverse the pump the other way, either suck it out or blow it out if it's before the pump. And they can handle a higher percentage of solids than a typical progressive cavity pump can, which has several benefits. Also, it means you don't have to water it down after the tank, but also if you've got a filter press beyond that, pumping a thicker percentage of solid obviously helps with that filtration process at the end and can reduce press times. And again, they're able to pass large solids. Typically, it's a bigger investment, but that's a typical example that we find day in, day out on quarries where they're struggling. And it's just a case of putting the right technology in the right place. Lives can be made a lot easier.
So just going to touch on the site water discharge side of things under our brand at Enviro Hub. So as mentioned at the start, this is something that EA are getting hotter and hotter on. Anyone anyone that's discharging any level of water off-site for longer than a 3-month period has to now requires a permit to ensure they're compliant. That permit will come in various ways. It might be a standard permit from the EA, simply says you're now permitted to discharge off-site, or they might say you have one of several parameters in place to be able to hit to be able to comply. For example, solids percentage or solids turbidity, pH, or within the limited flow rate. It's obviously becoming a much bigger thing for inner city concrete plants, and also anyone in that's operating in any area of specific interest, a triple SSI or any of those areas that are protected areas, and penalties and the fines relating to this are becoming more and more significant. Now, there's a really key point that I'd like to touch on here that has changed in the last 6 months in relation to EA permitting and compliance and also fines, is that previously the EA would talk to you, and if you had a breach, they would assume almost a best case scenario that breach had only just happened and that's the first breach. If you had a breach reported. However, now their assumption is that if they have reports of a breach, they will assume that you have been in breach until a period that you can demonstrate that you weren't in breach. So, for example, if you were doing monthly testing or quarterly testing or whatever, and you'd be assumed to be in breach until the last time you tested them and weren't in breach. So that's a really important point from a site discharge perspective. And the Environment Agency are really starting to promote the idea of live monitoring discharge, which I'll come on to shortly. Just some examples, you all know this, but some examples of the fines that are out there. We worked with a particular site down south that had previously received over £250,000 fine for discharging consistently high pH water, and this is something that's not going away. Who look down that list, there's plenty of other examples. It's not a one-off. It's consistent. It's a consistent issue, and it's taking more and more of the Environment Agency's time. So we developed this range, similar to, you may have come across the Siltbuster range. We developed this range of products to work with sites to be able to help them with these problems. A lot of our instances, a lot of the applications we'll be going into would be in the construction market. However, the quarry market is obviously particularly for any ongoing discharge is certainly this range is applicable to. I was going to show you the lamella tanks. These are for treating solids on a site discharge. For example, if you had a dewatering application from a quarry bottom and you are consistently getting solids in there and you needed to treat those solids to bring them within the EA permit, or for example, if you were on a concrete site and you wanted to reuse water from a wedge fit application. For example, we've just done a job for another site where we've helped them to, on an asphalt site, to be able to reuse the water they use to wash down the back of a truck to stop them having to discharge at all. And within that, they have to treat the solids. So this is a lamella system where you operate a series of plates and the water flows over them and separates the solids out quickly and effectively. If you look on the left-hand side, we've got a little video coming up. Shows the effectiveness of the system turning a very brown, mucky water into a visibly clean water. And then this on the right-hand side, you'll see what the product looks like coming out the bottom of the lamella. The importance of this is that obviously you can reduce the amount of lagoon space if you are obviously if you're using this from a water treatment perspective as part of your circuit, but also it's a very in a very small area you can treat pretty heavy solids into a clean water and compliant discharge, which is particularly appropriate for, as I said, concrete sites or inner city sites that have got limited space. I'm just going to flick through these because they're a bit detailed, but obviously pH correction is really important. That's something that we work with sites to do as well. But the one thing I really wanted to talk to you about on this, conscious of the time, is live monitoring. Now, as I said, it's becoming more and more important from an EA perspective. And previously, live monitoring has been of discharge has been, or any flow around site reporting online has been very, very costly, and it's been avoided because it involved a huge amount of work to install, running cable runs, all that sort of thing. We have a system which is an option, which we've put into a number of sites. In fact, actually, I don't know where it falls into North Wales, but we've just put a couple of these systems into Tarmac Dollier, where we are measuring live flow, pH, and solid content. Now, where this is different to any previous solution is that it doesn't use phone signals to transfer the data to the cloud. It uses low frequency radio waves to a gateway on site, meaning that you're not reliant on a SIM card, for example, which on a lot of quarry sites doesn't work. Uses virtually almost next to no power. You can run it on a very small solar panel, and it gives you the ability to log online, for example, as you can see on the screen here now, any live data. And within that, you can set up warnings and alerts, and we run on a traffic light system. So, for example, if you were all good and within your permits, it would be green. If you were approaching the soft limits of any of your parameters within your permits, it would be amber. And obviously, if you breached any of those parameters, it would go red, and it would text you or email you and alert you, or automatically shut off a valve, shut off a pump, divert the flow, etc. The system has got the capability to do all that inside one very cost-effective solution. And also, unlike any other system that's been put forward before, there's not a massive ongoing cost to this. Very, very low cost. And what's more, we've spoken to the Environment Agency about this product range, and they're very happy about the demonstration for using this portal and these live reports. You can print off a weekly or a monthly report to demonstrate to them that you've been compliant over a period of time. Now, I've flown through that latter section quite fast. Got lots more I could go through, but conscious that we're running quite a bit over time. So I'd be glad to answer any questions, Mark. I hope that's been useful. Anyone's got. Just going to touch on this quickly before you say anything. We can share with anyone. We have our own online training academy, which gives training on all aspects and areas of quarrying from a pumping perspective and a compliance from a discharge perspective, that is available to all. And if you're interested, please let us know.
That's great, guys. Thank you for that. Has anybody got any questions?
Nathan, it's Mike Davis from Svelco. Just a quick question on your Enviro Hub. Does that actually do turbidity as well?
Correct, yeah.
So it will measure turbidity?
Yeah, so measure turbidity as part of the process, and then you could record that online, live.
The three key things are flow, turbidity, and pH.
Yeah.
That's monitoring. So you've got like a threefold information strand coming through.
If I can ask a question, Stephen Cross from Hanson. If the drag flow dredger, then you mentioned 120 tonne an hour. Is that solids movement or that solids and water?
No, that's actual solids movement. Yeah, so you might have a flow rate that's substantially higher than that. You probably find you're operating around about 600, 700 meters cube or meters cube an hour in terms of flow rate. But yeah, 120 tonnes an hour of production.
And what sort of range is that for that type of machine? And what's the minimum and maximum? You know, if you're moving silt, that would be sort of a temporary or a small, I guess.
Yeah, so there's a range of products within that range. The smallest unit is for example, I should have mentioned this, but the Mount Sorrel one I showed you on the screen, that's an 80, that does about 18 tonnes an hour. There's a 50 tonne an hour module, and there's a 100, I think they're 150 tonne an hour, isn't there?
Yeah.
So yeah, but there's definitely the smaller end and the larger end in, yeah.
Okay, and then it was like 120 tonne an hour at a kilometre with no booster pump?
Sorry, no, there is a booster pump on that line, sorry.
There is a boost, okay.
Yeah, that pumps to the shore, and which is pumping approximately 350 to 400 metres to the shore. Right. And then there's a booster pump doing the last leg up to the plant.
Okay. On that particular installation, the booster pump was already there from a previous large-scale dredger, which we managed to rework for the smaller dredger.
Typically, Ian, on a dredge like that, you'd minimise wherever possible, minimise the size of the equipment on the dredge itself. So you do as small as possible dredge pump on the dredge, because obviously the costly bit is the dredger itself, the floating everything on the water. Yeah. So you make your pump as small as possible, and then do as much as possible with the booster pump, if that makes sense.
Mm-hmm. Yeah.
Good. Well, thank you very much for all the time. Really appreciate it. And anything else, I'm sure Louise will circulate our contact details. Any other further questions following this, be glad to talk.
No problem at all. And if anybody wants your email address, Nathan, it's no problem to get in touch with myself. Great stuff. Thank you, everybody.
No, thank you.
Thank you, gentlemen. Very good.
Yeah, thanks very much, guys.